you were factoring trinomials, but the lead coefficient was 1. The lead coefficient will be larger than 1 in this lesson, but the process is the same. You still look to the last operation sign. And if it's positive, then you know your signs will be same. And you'll look to the first operation sign to see if it's negative or positive when they're same. In this case, though, for number 1, our last number is negative. So that means our signs will be different. And what's crazy about this, with the lead coefficient being larger than 1, the last thing we can really place is the operation sign. So we're going to have to wait till the end to figure out how to put it in. So this time, and we still ask, is there a GCF? We will think about that with every question. There's not one with 7, 33, and 10. Luckily, 7 is a prime number. So we don't have a whole lot of options. We're going to have to factor the first number, factor the last number, so that we can figure out how to place to create the first and then to create the last. So with factors of 7 and 1 for 7, I'm just going to put the 7 first. We can't put our signs yet. And we still have an M. All right, and then it's factors of 10. 1 and 10, 2 and 5. Which then would be 5 and 2, 10 and 1. All right, what we've got to do, how do we check this? What's the process we use to check our answer? FOIL. FOIL is going to stay in the forefront of our mind while we work these problems. First and last will be no big deal. The outer and inner is where that middle number will be created. So our options are 1 and 10, 10 and 1, 2 and 5, 5 and 2. Okay, to mix it up. To create outer, remember it's going to be your 7M times the last number. And then the inner is those two that are right in there in the very middle. So what's 7 times 10? 70. Are we going to be adding or subtracting to get to 33? Subtracting. And then 1 times, so if we have 70 and 1, that's not going to get us to 33. 7 times 1 is 7. But subtracting 10 as your inner will only get us to 3, not to 33. Before we go any further, what I'm saying, is that making sense? Yes. To create your outer and your inner, you're having to use that 7 when we do our outer. You multiply with it.
You multiply with the 7, and why are you subtracting for the inner?
So you figure out your outer and your inner. Our last is negative 10. Which means the signs are not going to be the same. So to create that middle number, we're going to subtract. Because when you combine like terms with unlike signs, you're going to subtract. And then the larger number needs to be positive. So 7 times 5.
35.
7 times 5 is 35. And then 2 times 1 for our inner is 2. What do we get when we subtract? 33. And that's really what we're looking for. But I'm going to say this. Let's look at the last one just to be sure. So 7 times 2 is 14. And then 14 minus 5. So do y'all see that the only option we have is 2 and 5? So we're going to put our numbers in next, 2 and 5.
What would happen if you did 5 and 2?
Let's look at that in just a second. Then we've got to figure out where the plus and the minus go. It is the creation, what you get when you multiply. So when you multiplied 7 times 5, we got 35, right? That's the number we're talking about. And then the other number is 2. Which one of those is larger? Obviously, 35. So the creation for that needs to be positive.
So 5 is positive and 2 is negative?
Yes. Now, you asked if we did 7m minus 5.
Yes.
And we had m plus 2. Okay, let's see what happens when we FOIL. Your first will work and your last will work. But 7 times 2 is 14. And 5 less gets us to 9, not 33.
Okay, thank you.
And that is where the classic mistake comes in. That every year I have people that use the right factors, but they don't put them in the right spot. And if you don't FOIL, even if you just do it in your head, if you don't FOIL to see that you made 33, you don't want 9, which was what you would get with 14 and 5. So be sure to check. So before we go any further, is there a question? No? Everybody's comfortable? All right.
What's your answer?
So your final answer is 7m minus 2, m plus 5. And when you, like I said, when you FOIL it, you'll see that that's what you get for your final answer. But 35 minus 2 gives us the positive 33. See what you can do with number 3. Remember that 2 is the only even prime number. Oh, what is the coefficient in front of that middle k? 1. Will your signs be the same?
No.
So you're going to be subtracting. And we can't put in our plus or minus just yet. What are factors of 1?
1.
So the setup is easy, but figuring out the signs. So, 2k what?
Plus 1.
2k plus 1.
So if the last one is negative, then the first parenthesis is going to be positive.
Hold on, and I think I looked at the wrong key. My bad. It's 2k minus 1. Because I'm looking over at the test we just took. 2k minus 1 and k plus 1. And here's why. When you do outer and inner, the larger number needs to be positive. So 2k times a positive 1 gives us a positive 2. Or 2k. And then the negative 1k. But that,
You know which one needs to be larger?
the first operation sign.
Oh, okay. Is this type going to be on the quiz on Friday?
I'll let you figure that one out. We've talked all about that. All right, number 5. It's on the board and everything. Number 5. What do we do?
GCL.
And what would that be?
Area.
Bigger.
6.
6. So what are we left with? 5x squared minus
12.
what is 6 times 2?
12.
12, and this ends in a 6. So it doesn't end in a 2. So 16. And then, what would the last number be?
12.
There's our 12. Now, we have factored this. We've removed the 6. So the problem we're going to work with, the trinomial, is the 12 and negative 16, not the 72 and negative 96. Okay? So we'll start with factors of 12, factors of 5. Will our signs be the same?
No. Yes.
Yes. And what will the signs be?
Negative.
Negative. To get a positive 12, we need same signs. But we look to the first sign to see that it is negative. All right? Luckily, 5 is a prime number. So we don't have options for it. Just 5 and 1. So we can go ahead and put a 5x. And I'm going to bring the 6 down because we need our GCF to remain with us. And we can put a minus because the signs are going to be the same. And an x and a minus. All right. Factors of 12. What would that be? 1 and 12.
2 and 6.
I love how you're figuring that out. I need it in order. 2 and 6.
3 and wait.
Yep. 3 and 4. And then we start over 4 and 3. So forth. Now, let's look and see. We can write them down. And I'm going to use different color. Just kind of underneath. I'm not going to put anything in our parenthesis yet. So 1 and 12. 12 and 1. 2 and 6. 6 and 2. 3 and 4. 4 and 3. All right. One of those 6 options will work. You just try them. So you know you're going to do outer, which means multiplying by 5. So 5 times 12 gives us 60. And then 60 plus 1. That's not it. We've got to get to 96. Okay, so I can cross it out. Well, 5 times 1 is 5. 5 plus 12. We're not there. Y'all see how it didn't work?
Yes.
All right. Then 5 times 6. 30. And then 2. That's 32. And then we would have 5 times 2. 10. 10 plus 6. Oh, and I apologize. We're not trying to get to 96. We're trying to get to 16. My bad. My bad on that. I looked at the wrong number. So, did we get to it yet?
Yes.
Which one?
2 and 6. 6 and
6 and 2. So I'm going to cross that. But I want to show you 5 times 4 is 20 plus 3. You know, and that's already too big when you start. And then 5 times 3 is 15, but plus 4 gets it too big as well. So do you see out of all 6 of those, only 1 works. So we would have 5x minus 6, x minus 2. And when you FOIL it, you end up with 5x squared, and then minus 10x, minus 6x, and then plus 12. And that gives us the negative 16x. Then you would take your 6 and distribute it to get back to your 30x squared problem. All right, so do you see how that worked? Bahar, you have a look.
No, I was just copying it.
You sure you're good?
Yes, ma'am.
Okay. All right, let me know when you're ready. We're going to move to the back page. You're good? Okay. So let's look at this problem here, number 13. Did they share any factors?
Yes.
They would if 19 happened to be 18 or 20. But 19 prevents the 6 and 10 from being able to remove factors, okay? So, is 6 prime? No. So we're going to have to look at it. Factors of 6, 1 and 6, as well as 2 and 3. And then factors of 10, 1 and 10, 2 and 5. Are we going to use same signs or different signs?
Same.
And what will they be? Positive. So luckily, we're just going to be adding and not trying to subtract to get anywhere, which kind of makes it easier. So we'll start with 6 and 1. So 6x, we know it's plus, and an x, and we know it's plus. All right, so here's a rule that y'all need to really hang on to. When you're through creating the binomials, the numbers inside the parentheses cannot share factors, okay? And we have a 6 as one of our numbers. It cannot be combined with the 10, nor can it have the 2 inside the parenthesis with it, because they would share factors of 2. So that means we could have a 1 here and a 10 here, or we could have a 5 here and a 2 here. Those are our only options. And do y'all see why? No?
Why can't you flip them?
Is it because you're adding? Because it can't be.
Because when you finish with a binomial, they cannot share factors. And if I put the 10 here, 6 and 10 would share. And if I put the 2 here, 6 and 2 would share.
Okay.
So that you can't put that. So let's see if this works. We're adding to get what number? 19. What is 6 times 10?
60.
Well, that's too big. I mean, we're already too large. What is 6 times 2? 12. All right, that's good. 12 plus 5 for your inner. 17. Not quite large enough. And we can't manipulate it. We can't go, well, we'll just take 2 from 10 and make it 8. No, you just move on. Okay? So does everybody see why 6 and 1 do not work? Anybody have a question?
So is it prime?
Nope. We now get to go play with 2 and 3. Other factors of 6. Yeah. So I'm going to erase what we have. A big eraser and very light writing is helpful. All right, wait, Mamie, you have a look.
I'm just confused. Wait.
Okay.
So all because it didn't work, we erased the whole thing and restart?
Well, 6 and 1 won't work. I mean, we could have left the parentheses and just erased the 6 and the 1. Sure. So we start over. 1 and 6 are not our numbers. So 2x plus and 3x plus. Now, if we can't find something that works here, then yes, it'll be prime because there are no other factors for 6.
Wait, but that only equals 5.
2 times 3 is
Oh, you're multiplying.
multiplying. All right. Remember, we can't share, we can't put a number in with 2 where it shares a factor. So the only option for 2 for the first one is a 1 here and a 10 here. And then the other option would be a 5 here and a 2 over here. So then let's do the math. 2 times 10.
20.
Well, we already started off too big. We have 1 hope left. What's 2 times 2? 4. 5 times 3? 15. What's 4 plus 15?
19.
Woohoo! Winner, winner.
Wait.
How'd you get?
How do you get 15?
Yeah.
5 times 3.
5 times 3. You're inner. Yeah, we have a number in front of that second x this time. It's not a
Wait, so if
1.
you have a number in front of the second x, you have to multiply.
Yeah, to make the inner. Sure
What did
do.
you do with the other 2?
Well, the 2 times 3 gives us the 6x squared.
Well, I meant like the
Right here,
bottom, the last 2.
the last. So then your outer is 2x times 2. But you can multiply them. They can share factors that are multiplied, but they can't be in the same parenthesis.
Okay.
So 2x times 2 gives us the 4x. 5 times 3x gives us the 15x. Put an x there. Which gives us 19x. And that's what we're looking for. for the middle number. I heard a huff. Are you good?
I'm just tired.
Me too. All right, questions? This is the first one where you've had factors at the beginning of both binomials. You have to use them when multiplying out the other part, okay? So do you have a question about this? This is a kind of like, this is why it's the 1,000 puzzle piece, trying to piece it together.
What if both the signs are negative?
Then you would have still added and you would have had negative numbers. And it would have been a negative 19x we were looking for. Or do you mean if both the signs had been negative in the problem, then you would have been subtracting to get 19?
So would both the signs be negative then?
No, one would be positive, one would be negative because the signs have to be different to make a negative 10.
So then the bigger one would be negative.
Yes.
Okay.
All right. Good with this one? Look at 15. You work it. Do they share factors, 9, 71, and 90?
No.
No. 9 and 90 do, but 71 prevents the break. So factors of 9? 1 and 9, 3 and 3. Okay, here we go. Factors of 90.
91.
So we have
45 and
1 and 90, 2 and 45,
3 and 30.
3 and 30.
5 and 18.
Well, 4 won't go, 5 and 18. If 2 and 3 go, then 6 goes. So 6 and 15. 7 won't go, 8 won't go, 9 and 10. So, will your signs be the same?
We have a lot.
Yeah.
No.
Signs will not be the same, so we are subtracting to get 71. So, play the puzzle game. No. This is why, you could do it with a dry erase marker on your desk. You could do it really lightly with a pencil, but just have an eraser. But a dry erase is always helpful. Because you're not going to have to worry about first and last. You don't have to foil it all. You're just trying to create 71 with outer and inner.
Wait, so can you do 3x?
Sure. You can have, as your beginning, let's talk about that, Mamie. I'm glad you asked that. You can have 3x here and a 3x here because they won't be in the same parenthesis. But that means whatever you put with that 3 cannot share a factor with it. 1 and 90. Can you even use that? No, because 3 goes into 90.
You couldn't use it anyway, so could you?
You can't use any of them.
You can't use that one. Why can't we use 2 and 45?
45.
45. What about 3 and 30? No. What about 5 and 18? 5 works, but not 18. 6 and 15. And 9 and 10. So there's a huge hint. 3 and 3 won't work. Because you can't find a number to go in the parenthesis with 3.
But if you had 9, it also wouldn't work because that's.
But you have an option with 1. The only number that cannot go with your 1x is another 1. So like 1 and 90, we can put the 1 with the 9 and the 90 with the 1x. You know what I'm saying?
Are we subtracting
Subtracting to
for
get,
both signs?
well, you don't know where the signs, the last thing you'll do with this problem is place the signs.
Okay.
Because you've got to find this larger number that's negative. And we won't know which one that is until you have finished creating it. So now you just sit and multiply. 9 times 90, which is what?
That's going to be too big.
810. Well, we'll never get to 71, so we can scratch
Wait,
it
so
off.
we're trying to get 71.
The middle number. We're subtracting to get to 71. 9 times 45 is going to be 300 something. So that's going to be a little big. 3 and 30. Can we even use 3 and 30?
No.
No, because 3, it shares with 9. All right, 5 and 18, how can we place that?
You have to
What would go with the 9?
say 5.
The 5. And then we would have an 18. 9 times 18. It's going to be 100 something big. Minus 5 is not going to get us to 71. Can we use 6 and 15?
No.
Because 3 goes into all of them. 9 and 10, how do we place it?
The 10 with the 9.
The 10 here and the 9 over here. We don't have an option. What's 9 times 9?
81.
Minus 10.
71.
There you go. Now, the last thing you have to do before foiling to check your work is to figure out where the signs go.
The first one
The
will
9 has the negative.
The 9x has a positive.
be the 10.
The 9x plus 10. And then.
But 10 is larger than 9. So why didn't you put the negative with the 10?
Then it would be negative 81 when you're trying to get.
Perfect. It's what you're trying to make. We're not worrying about the 9 being larger. We're worrying about the creation of it, which is 81. So it made 81, and this makes 10. Which one do we want to be negative? Would be the 81, so the 9 has to be negative. Yes, ma'am.
Do you have a
Sorry.
So before we move on from 15, look at it, think about it. It's a puzzle piece. It is workable. Now, I will say this. These are our only options here. And the very last one was where we found the answer. If that one hadn't worked, what would the solution be? Prime. But it worked. Don't give up. Okay? Like I said, this is a puzzle. Do not give up. What about 18? Look at 18. Will the signs be the same?
Yes.
Yes. What will the signs be?
Positive.
Addition, positive. Do 10, 49, and 18 share factors? No. 10 and 18 do, but 49, if it were 50 or 48, we could say yes. And there are no shared variables. So, what are factors of 10?
5 and 2.
1 and 10, 2 and 5. Factors of 18? 1 and 18, 2 and 9, 3 and 6. Go play. Figure it out. The lovely part is you can go ahead and put your M and plus. And you're going to be doing addition to get to 49. You're also limited by not being able to share factors. Because 10 can't go with 18, 2, or 6. And you do 10 and 1. And 2 cannot be with 18, 2, or 6.
if you put the 1 in the first bracket, like after the M,
With 1 and 10, or with 2 and 5?
you're adding it.
But are you saying put the 1 with the M, or are
No,
you
like
saying
behind
what do you have as your
5.
5 and 2?
Oh wait, never mind.
Okay.
If you have like 2 and 5 together, what do you like for the second one? How do you like multiply? Because you have to multiply both of the things.
Well, you're saying you're not using 1 and 10?
Yes, ma'am.
Okay, so if you have a 2 here and a 5 here. Or you could have a 5 first and a 2 second. But then what's your question?
Like, you have to multiply the 5 by something too,
You're going to multiply it by this number right here, your inner.
which is what you multiply and then add.
So we can't put the 18 with the 2 because they share factors. So the 18 has to go here, and that means the 1 would go here. The 2 from the 2, 9 can't go with the 2, so the 2 could go here and the 9 here. And then the same thing for the 6. It can't go with the 2, so the 3 would. So the 1, 9, and 3 will be multiplied by 5 to create the inner. And the 18, 2, and 6 will be multiplied by 2 to create the outer. Is that clicking? It's a lot. It's definitely like a big old puzzle. But you cannot say, I'm confused, I don't get it, I give up, okay? Because it's just having to keep working through it. Do you have it?
Oh yeah, would be.
No, don't say it just yet. I still but I'll call on you for the answer. We're about there though. Because I see some that are still working. All right, what'd you get, Carlin?
2n plus 9, 5n plus 2.
Yep. So 2 times 18 is going to give us 36, but 36 plus 5 will only give us 41, and we need 49. 2 times 2 is just 4, but 9 times 5 is 45. So 45 plus 4 got us to 49. 49.
Wait,
Who said wait?
I'm confused.
Why did you add so many with the? You can just add any of them.
Well, I worked through. This is we just determined that 10 and 1 would not work, right?
9 times.
So 2 and 5 are our options to create the 10.
So you're multiplying the 2,
You're working
the inner ones.
You're doing the outer,
Okay.
and then you do the inner and
that
add.
makes 49. Okay.
Mm-hmm. And then if you did the last one, 2 times 6 is 12. 12 plus 15 would not get us far enough either. But it would not get us to 49. But this is where you realize you've got a number in the second binomial that's got to be multiplied with. We haven't had many that have had a number other than 1 in that second binomial. So don't forget to use it. Then look at 21. 5, 2, and 16, do they share factors? No. Luckily, 5 is prime. Woohoo! Those are the easier ones. Now, 16. What are our factors? 1 and 16.
2 and 8. 3. 4 and 4.
4 and 4. 3 won't go. You know the rule. Add your digits. 1 plus 6 is 7. If 3 won't go into 7, it won't go into 16. All right. Are we going to be adding or subtracting to make the middle number? Subtracting. All right. Then we have this y squared in there. at the end.
You just added to
Where?
the last.
Excellent. That's going to be part of your last. Fabulous, Parker. So we know we're going to have a 5x, and we're going to have an x, and we know at the end of each we'll have a y. Can't put our signs in until the very end because they're different. All of the numbers can be shared with 5. They don't share any factors. So we could have 1 and 16, 16 and 1, 2 and 8, 8 and 2. 4 and 4 only happens one way. And we are subtracting to get 2. You figure it out. My bad. I think I told you to look at 21, and I pulled down 22.
It's 8 and 2.
But we'll work it and throw the other in. All right. It's what?
8 and 2, right?
Where do you write them? What does the 8 go with?
The
5 or the 1?
the 5. Wait.
Yeah.
The 5.
Which one's negative, the 8 or the 2?
The 8. Wait.
So we've got,
The 2.
yes, 10,
But I thought the bigger number had to be
the created bigger number.
Huh?
5 and times 2 gives us 10. 8 times 1 gives us 8. I need the larger number, which is 10,
So the bigger, like.
the created number. Yeah.
Okay, that makes sense.
So the 2 will take the negative because it makes a 10. All right, now I'm not going to say anything. You work 21. Oh, this one's super easy. Oh my gosh, I'm not saying a word because everything's prime. Well, the 20 is not, but your numbers you're working with will be. Are you going to be adding or subtracting?
Subtract.
Subtracting. So what did you get for this one?
Is it 1 and 7?
Well, sure, but
Positive 1 is negative 7.
which goes where? What goes with the 3?
The 7? The 1.
So plus,
1B.
Plus
Oh,
1.
yeah.
And then minus.
because this would give you, oops, my bad. No. So this would be 3u squared. Your outer gives you negative 21 v, or uv. Your inner gives you plus 1 uv. And your last gives you negative v squared. And when you combine your like terms, you get negative 20 uv. And that's what you're after. Questions? Is it making sense? All right. There's another method that you can use. It's It's called Bottoms Up. I have uploaded in your assignments link the link for that video. It's totally optional. There's several succinct steps to it. But it's kind of a cool way to work it. So it allows you to have the lead coefficient for a temporary moment to be to be a positive 1. It removes the lead coefficient. And then you factor it and then you put the lead coefficient back in. But it's kind of neat. So I encourage you to just watch it as another option for working these. Your homework is to complete the odd problems that we didn't work together. Just the odds. And to be ready for your quiz.